Hi, everyone, and thanks for joining me today for episode 821 of People Behind the Science. I'm Dr. Marie McNeely, and today we're excited to reshare our conversation with our guest, Dr. Chad Orzel. Listeners, Chad studies ultra-cold atoms to improve our understanding of atomic physics. He uses lasers to drop the temperature of samples of atoms to just millionths or billionths of a degree above absolute zero. At these very cold temperatures, the atoms move very slowly, and interesting quantum effects arise. And in our interview, Chad shared some cool details about his research, and he gives us a peek into his career path and life outside the lab in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to introduce you to our guest scientist, Dr. Chad Orzel. So, Chad, welcome to our show today. How are you?
Good. Thanks for having me on.
Absolutely. Well, we're excited to learn more about you and the wonderful work that you do. But I want to start by giving our listeners just a little bit of background first. So, listeners, Chad is the R. Gordon Gould Associate Professor of Physics at Union College. He's also author of the popular science books, How to Teach Physics to Your Dog, How to Teach Relativity to Your Dog, Eureka, Discovering Your Inner Scientist, and of course, the soon-to-be-released book, Breakfast with Einstein, The Exotic Physics of Everyday Objects. And in addition, Chad is a regular contributor to Forbes Magazine for science blog articles. He received his bachelor's degree in physics from Williams College and his Ph.D. in chemical physics from the University of Maryland. And before joining the faculty there at Union College, Chad conducted postdoctoral research in the physics department at Yale University. And Chad, today we're excited to learn more about you and your work. So can you start by telling us a little bit more about what you like to do when you're not doing work?
So I have a 10-year-old daughter and a 7-year-old son and a 1.5-year-old puppy. So it's not hard to find things to occupy my time outside of work. Mm-hmm. I also enjoy playing basketball. There's a group of faculty and staff who play at lunchtime a few days a week and try and do that. And I read genre fiction, mostly science fiction, fantasy, though there's precious little reading time these days between the kids and the dog.
Totally understand. So are the kids into basketball as well?
Not that much. They're currently really fired up about soccer because it's the tail end of the rec soccer season right now. So that's been their big thing. Basketball hasn't caught on that much with them. My son really spends a lot of time trying to wrestle me. So he's signed up for a wrestling thing this winter. So he's going to give that a try some kids his own size. So.
Very cool. Well, Chad, it's great to hear a little bit more about life outside of science, but I would love to talk about your work today as well. So how do you describe what you do to someone who's not familiar with physics or the particular work that you're studying?
My area of science is I come out of the ultracold atoms community. So what we do is we use lasers to make samples of atoms very, very cold. And you do this because when an atom absorbs or emits light, it gets a little kick from the momentum carried by that photon. And if you arrange things cleverly, you can set that up so that you use those little kicks to slow the atoms down. And temperature is a measure of how quickly the atoms in a sample are moving. So the slower you make them, the colder the sample is. So we can, by shining light on a sample of atoms, we can reduce their temperature down to millionths or even billionths of a degree above absolute zero. And then at that point, weird quantum effects start to really come into play because the slower things are moving, the more wavy they act. And you see a lot of odd quantum phenomena start to show up when you deal with ultracold atoms. So it's really exciting. It's a tool that now it's been around for almost 30 years, but really revolutionized atomic physics and opens up huge new areas for people studying the properties of atoms and molecules and how quantum mechanics comes into play in real systems.
Awesome. Well, Chad, great to hear about your work. And I'm curious, do you have a favorite atom to work with in these ultra-cold scenarios?
My Ph.D. research, we used xenon, which is the heaviest of the stable rare gas atoms. So I have a soft spot for that, though that's really difficult to work with. The lab I have on campus is set up to work with krypton or argon, which by a happy coincidence, you can use the same lasers to do both. So that's a nice feature of that system. The big one that lots of people use is rubidium, which is one of the heavier alkali metals. And that just totally by chance turns out to have really convenient properties in a lot of respects. So there's a joke that rubidium is God's atom. Its laser wavelengths that you need are sort of convenient. The temperatures you get have nice properties. When the atoms collide with each other, they don't do anything too wacky. So that's the one that's probably the most widely used laser cooling atom.
Interesting. Well, Chad, I look forward to chatting more about this throughout our interview today. But I do want to take a moment here to talk a little bit more about what motivates you. I think hearing you talk about your projects and in looking at some of the books you've written, you can tell you're passionate about physics. But do you have other things that motivate you? Maybe a quote or a saying or a motivational force in your life that really keeps you going?
If I need to motivate to do something, I really tend to go more for music and fire up favorite albums, and that helps me power through whatever I need to get done. Motivational quotes, I'm sort of partial to. Michael Faraday famously was asked for what the secret to success in science is, and he replied that it's 3 words. It's work, finish, publish. And I think that captures a lot of stuff, which is whatever you're doing, you need to actually do it. You need to focus and actually work on the thing that you're supposed to be working on and not just faff about on social media or whatever else. The other thing you need to do is you need to eventually finish whatever project you're on. And that doesn't mean that you get absolutely every single detail nailed down. That means at some point you have to say, okay, this is complete enough that we're going to stop here and we're going to move on to the next thing. And then the most important thing is to publish your results and tell people what it is that you've found, because that's what separates science from alchemy, the open sharing of results. And that's the thing that allows other scientists to duplicate what you've done and use what you've done as a foundation to build on and move on to newer and more exciting things. And that's what allows the compounding progress that you see. That's the scientific revolution, really. The other thing I do is I write books. So it carries over very nicely to that too, right? You have to work, finish, publish.
Absolutely. Well, I think that is a great quote for both the writing and the scientific worlds. And you mentioned Faraday, and I think he's one of these big motivational, inspirational figures in science. But I think there are so many others out there. Were there people in your life, Chad, who really inspired or motivated you, who maybe served as role models or you just looked up to?
I had the really good fortune of working in graduate school for Bill Phillips, who shared the 1997 Nobel for developing laser cooling. And he's really a terrifically admirable person. He's an outstanding scientist. He's also an incredibly nice guy and very generous with his time and helping students and postdocs and just extremely fired up about science all the time. So he was an absolutely fabulous person to work for. And I often say that the stuff that I do with communicating science and speaking to general audiences, most of the good things that I do in terms of explaining science to other people, I've just lifted directly from Bill. He was a terrifically inspirational person to work for.
Awesome. Well, it's wonderful to hear that you had such a great role model and particularly emphasis on this science communication element. And I think this is something you do a fantastic job of. So can you tell us a little bit more about these efforts, some of which we mentioned in our introduction today?
Yeah, I spend a lot of time explaining science to non-scientists. I started doing a blog about physics all the way back in 2002, which in sort of the internet time is just after the dinosaurs and just before the giant armored sloths.
Right.
So it's a long, long time ago. I looked around at that time and there were a lot of people doing blogs that were just general political commentary. And I have political opinions, but I don't have any expertise in that area, that I don't bring anything to the table. But there was a guy named Derek Lowe, who's a chemist. He now has a blog that's sponsored by Science Magazine. And he had a blog about pharmaceutical chemistry. And I said, well, he's talking about science there. I could do that. I can talk about physics. So I started a blog where I discussed physics and life in academia. And that really took off. So I ended up joining science blogs. And then completely by accident, that led into the book publishing career.
Very cool. Well, we've heard about your beginnings of your scientific communication career, but I'd love to go back even farther, Chad. And can you tell us what first sparked your interest about science or maybe physics specifically?
I can't remember a time when I didn't want to be some sort of scientist. There's a family story about me in kindergarten or so visiting my grandmother's office. And somebody there asked, what do you want to be when you grow up? And they're expecting me to say like fireman or astronaut.
Yeah.
And what I said was, well, either a paleontologist or a marine biologist.
Oh, wow.
I eventually got into physics in high school more. I had a really good physics teacher my junior year in high school, and that focused me in that direction. And the thing that I find appealing about physics is it's sort of the cleanest of the sciences in a lot of respects. What physicists do is to take really complicated situations and break them down to sort of the most simple and universal cases that you can make out of those things and strip all of the complexity down to something that's really simple and clean and elegant and try and find universal principles that describe that. And then you can build back up to the much more complicated situations. And I like the simplicity that you end up with in physics. I have a running joke on Twitter that I'll link to articles that come out about new discoveries in social science things with today and reasons I'm glad I don't work in social science.
Working with people is messy. Yeah.
Yeah, it's psychology where you have to worry about like, well, did I word the question correctly?
Were they being honest? Yeah.
Are the people lying to me? Did they not have lunch, so they're cranky and that changes all of my results?
Right.
There's a whole lot of factors that just aren't there. And it's much nicer, I think, working in physics for that reason.
Excellent. So when you were in undergraduate, did you have some opportunities to work in a physics lab?
I did. And that's actually the thing that got me into academic physics specifically. Toward the end of my freshman year, one of my professors said that there's an opportunity for a summer research position doing essentially lab development for the physics department. And I found that was a lot of fun. I had sort of a general, here's a description of a lab that somebody does at another institution, make this work, figure out the best way to make these things actually work and write it up in a way that other students will be able to implement here. And fiddling with that and finding all of the little quirks of the apparatus and how to make it work most smoothly was a lot of fun. And I did a similar thing the next summer, and then I got into a more research-oriented job and started my undergrad thesis. And that's where I got into laser cooling. That's one of the reasons why I am where I am now, that I really enjoyed that experience, and that made me want to pay that forward in a sense. So when I was a junior in college, I had a meeting with my advisor who asked me, well, you're going to graduate next year. What do you want to do with your life after that? And I remember saying to him, it seems like you have a pretty good gig. How do I get your job?
Right.
How do I get to be a professor at a small college? So I went to graduate school specifically wanting to do that, to be able to get students involved in research projects and provide them the same sort of opportunities that made a career for me.
Excellent. So then what drew you specifically to Union College?
Well, the academic market is you kind of go wherever there's a job. And Union was one of many places I applied to. They're the one that interviewed and then hired me.
Right.
So,
and you must like it there because you've been there more than a few years.
I started here in 2001, so this is my 18th year. And it's actually an ideal location in a lot of ways. I grew up about 2 hours south and west of here, and my wife is originally from the Boston area, which is about 3 hours east. So when we first moved up here, it was perfectly situated. It's like midway between both families. And we're about an hour from where I went to college, too. So I love this part of the world.
Fantastic. Well, Chad, I'm glad to hear that your career trajectory, your path that you took to science has a happy ending there at Union College. And we've talked about your career path so far, but I'd love to hear a little bit more about your research. And do you have a project that you're working on right now that you are just the most excited that you want to share with us today?
So right now we're in sort of an odd position because we're in the process of setting up a brand new shiny science building.
Ooh.
So the big things are kind of on hold in my lab at the moment because I don't want to spend a huge amount of time getting things working when I know that, next summer I have to take everything apart and move it to a new building. But we've had for the last few years students working on sort of smaller projects that are a little more portable. One of which is I have a student who's been working on an optical tweezer system, which half of this year's Nobel in physics went to Art Ashkin for developing the idea of optical tweezers back in the 70s. This is a technique where you focus a laser like through a microscope objective, and you can trap small refractive objects in the focus of that beam, and you can use that to move them around. That's a really neat project. It's a surprisingly simple system to put together. You need a microscope, or you can build a microscope with appropriate lenses. And it works really nicely to trap and manipulate tiny little things. So we've had a couple of students working on that for the last few years. And we've got it around to the point where we're going to start talking to biologists about, we have this, we can do these things with it. Is there something that you think would be interesting to do with this system and its capabilities once we get through this?
Very cool. Do you have any preliminary thoughts on things that you would like to apply this to?
Not really. I don't know a great deal about the cell biology. So we did just recently hire a new colleague who is a theoretical biophysicist. So
cool.
I expect to be talking with him a bunch in the next few years about, all right, we got this thing. What do we do with it?
Well, Chad, that is very exciting. And we wish you the best of luck in the lab move. I know those can be traumatic times sometimes.
Yeah, it's going to be very disruptive.
Well, it'll be over soon before you know it, right?
I hope so.
And we talked about some of the different things that you encountered along your career path as a scientist. And I think there are so many challenges and struggles and frustrations, things like having to pick up your whole lab and move it to a different building. And I think these challenges are really important to talk about because you don't often hear about them in the scheme of the success stories that you usually see in the media. So Chad, do you have a favorite failure or a challenge or a struggle story that you can share with us today?
Probably the worst point of my career was when I was a graduate student. There's a qualifying exam at the start of the second year in graduate school. I went in to take that. It was a 2-day test. And the last question on the first day was just totally out of left field and really rattled me. And I had no idea how to approach that question. So that shook me really badly. And when I looked at the questions for the second day, I didn't immediately see how to do them. And I just shut down totally.
Oh, no.
I spent the whole second day of the qualifying exam just like doodling in the margins of the blue book. This was a disaster. And of course, 15 minutes after I walked out of the exam room, I knew the answer to the questions. They were not actually that difficult, and I just totally blanked on it. This was in the mid-90s. I remember going to a movie that night, which was Natural Born Killers, which was just out, and thinking, I could shave my head and go on a multi-state killing spree.
I'm glad you didn't.
I did get things back together. I had to do an oral exam to pass it and answered a whole bunch of questions from the exam committee. And the last question was, how did you screw that exam up so badly?
Nerves, yeah.
That was a dark week or two there, but got it together and then got back on track. There have also been a number of times later in graduate school, I had a whole year where just felt like every day I went into the lab and broke things. And there was a stretch of a few months when I was starting my postdoc where we just had to take everything apart and put it all back together because nothing was working right, and not for any obvious reason. So it was just like dismantle absolutely everything, put it all back together and see if it works better. Fortunately, it did, and we got some really great results out of it after that. But that was also a lot of very long days and late nights in the lab.
And at the end of it, you're like right back where you started. Right?
Yeah, but things were slightly better. And also that was useful because then I knew absolutely all of the details of how everything was put together, where frequently you come into a lab, particularly as a postdoc, that has existed for several years before you got there. And there's a bunch of stuff that they just sort of tell you, this is how this works. You do these things in this order. Don't worry about what's going on behind it, which is great if it's working. But if it's not working, then you don't necessarily know what to do with it. But since everything wasn't working, we took it all apart. Then when it was done, I knew how all of it worked.
Well, Chad, thank you so much for sharing some of these stories of your own of struggle and just some of the problems that you have to face and work through in science. I think I can definitely relate to some of the things that you mentioned. I'm sure our listeners out there as well can. That pit of your stomach feeling you get when you're looking at an exam question and you're totally blanking. And when you're going into work and you feel like you would have been better off just staying home because more would have gotten done if you had touched nothing today.
Exactly.
Well, thank you for sharing your own stories. But Chad, we don't just want to talk about the tough times in your career. So can you tell us next about one of your exciting successes?
The biggest one ultimately was the stuff I did as a postdoc. We were doing some experiments with Bose-Einstein condensation, looking at a quantum mechanical effect that happens if you take a bunch of atoms, cool them down to essentially absolute zero, and then chop that sample up into a bunch of pieces. And it turns out there's a relationship between sort of a quantum mechanical phase associated with the waves that represent those atoms and the number of atoms that are in a site, specifically the uncertainty in those things. So we could take a sample of atoms and chop it up into pieces that normally would have an uncertainty of about plus or minus 50 atoms. And we could reduce that to 2. We could push the uncertainty down really low and detect that by looking at the effect that this had on the uncertainty in the phase. And nobody had done anything like that at that point. And we got it to work, and it was super exciting and getting it out there. And one of the most fun things I ever did in terms of presenting was I went back to my group that I was in graduate school and gave a talk about this work there. And I had several different versions of talks about this. I brought the slides for like the 20-minute version of the talk, and it went for an hour and a half.
Oh, wow.
And at the end of the hour and a half, I still had 2 or 3 slides left. People need to go eat lunch now.
Right.
But there's just a constant barrage of questions, but I knew the answers to all the questions. So that was a blast. That was one of the most fun experiences I've had in a professional context.
Definitely. I think being able to share that excitement with people who are just so into your work is an absolute thrill.
And that group is both terrifying, but really fun to give talks to, because when I was a grad student, Bill Phillips has this thing where people will be talking and they'll say, okay, now before you leave that slide, and then he'll ask like a really tough question or really nail the details of something, which as a grad student was terrifying to see. But it's not in any way malicious. It's not like he's trying to trap you or demonstrate that you don't know something. It's that he really wants to understand it and wants to understand every detail of it. And if you go in knowing that that's coming and knowing that that's the reason, it's enormously fun to give talks in that context because it's a constant barrage of questions, but they're not mean questions, even if they're tough. It's because they really care about the science, and it's a great environment to be in.
Definitely. I think good for you as a scientist, because it might highlight some of the things that you perhaps thought you understood, but we're like, well, now that I haven't thought about that, right?
Yes, you really need to know your stuff. And the other Bill characteristic question is one that starts off with, don't you mean to say that, blah, blah, blah? And the answer is always, yes. I meant to say the thing that you just said.
Oh, that is fantastic. Well, congratulations on these successes. And of course, being able to go back to your sort of old group that you were working with and share some of the exciting success you were having there as a postdoc. And we've talked a little bit about your research, but I'd love to chat more about the author side of your life. I know you've written some phenomenal books, and we will put those out on our website for our listeners to find there. But can you tell us a little bit about what motivates you and excites you to write these books?
The talking dog books happen completely by accident. I really do carry on conversations with my dog.
Oh, I do too. Yeah.
Doing the dog's half in a silly voice because it makes my wife laugh. Now it makes the kids laugh. So I used to do this, and then I was in a silly mood one day, and I wrote a blog post about an imaginary conversation with the dog about the many worlds interpretation of quantum mechanics, and put that on the blog, and it got linked by Boing Boing, and 50,000 people read it that weekend. And one of them was an agent who contacted me and said, this would be a great idea for a book. I said, what? But thought about it, and I'm like, okay, I can see how this works. So we put that together as a proposal, and somebody bought it, and we published that as a book. It did pretty well, and so did the Relativity book. So totally by accident, I have a second career in publishing popular science books.
Well, that's awesome. So coming in with this experience of blog writing, was it easy or hard for you to make the transition into writing books?
It's different. There are days when it is completely horrible, and there are days when it's great. I've never really had trouble putting words in a row. That's always been a thing that's come kind of easily for me. So that part of it isn't necessarily that bad. The things that are difficult are when I need to write about a topic that I don't actually know as much about as I should, and then having to research a whole bunch of stuff. And 95% of what I learn in the process of reading about all of this science is never going to make it into the book because it's super complicated. It's math. It's really fiddly technical details or like little points about the precise definition of this or that, that if you try to put in there, it's just going to bore everybody silly. And figuring out ways to make these more abstract topics relatable is really hard. The current book, I have a chapter about its magnets. How the heck do they work? And the permanent magnets are ridiculously complicated. there's a whole bunch of physics at several different levels that goes into that, and figuring out, first of all, how it works. And then secondly, how can I explain this to people?
And at what level? Yeah.
Yeah. The thing that is worst about the book writing is there's a lot of days when I go to the local coffee shop with my laptop to write, and then I just end up sitting there for 2 hours clicking randomly on things on Twitter. And it took a while to sort of accept that that's kind of part of the process, because I'll have like a day or two of that where it's easy to just beat myself up and say, like, you didn't do anything today. But then after a few days of that, then what's really going on is somewhere in the back brain and the almost subconscious, things are turning over, and there comes a point where it all clicks. And then I sit down and I write 1,500 words about how magnets work, and it comes out okay. But the hard part is those days where just I sit down, I have 3 sentences on the page, and 2 hours later, I have 5 sentences on the page. And it's just miserable. But I've had to get used to the fact that that's going to happen sometimes.
I think most of us can relate also, just in terms of any sort of writing, whether you're writing a scientific paper or a grant application, you're just staring at that same sentence for hours.
Yeah. And a lot of it is just finding the right way into it, because they have this giant mass of facts about the thing, but there's some way of turning everything around and sorting things out in a way that then all of a sudden all these pieces fall into a row, and then it all becomes very clear. That's the hardest part of the business. But at the end, when those things actually work out, that's one of the most satisfying things to find out, okay, that actually came out really well.
Right. Well, Chad, wonderful to hear about your writing. And like I said, we will put your books on our website for our listeners. But are there any others that you'd like to recommend for us today?
There's a few books in physics that I like to plug that aren't super well known. I am fond of a book called The Theory of Almost Everything by Robert Erter, which is a book about the standard model of particle physics. And the thing that I like about it is there are tons of books about fundamental physics that have like a chapter at the beginning on the standard model of physics, and then everything else is about speculative extensions of the standard model, string theory or loop quantum gravity or whatever thing that the person is pushing. And we too often are in a rush to get from the stuff that we actually understand very well out into weird speculative things, theories that aren't proven yet. And I think the thing that I like about this Theory of Nearly Everything book is that it just focuses on the part that we know really well. And I think that's an underrated thing to do. Like, here is the thing, we actually understand all of this, and let me explain to you how it is that we understand this stuff so very well without getting off into the weird speculative stuff. So I think that's a terrific book in that regard. The other one that I've mentioned a bunch recently is Amanda Gefter has a book that is called Trespassing on Einstein's Lawn. It's actually about very speculative physics. It's about quantum physics, but it's also this family story where she and her father got really interested and excited about particularly the work of John Wheeler, who's a famous physicist at Princeton. And it's sort of this years-long family story about the back and forth between her and her father and trying to decipher Wheeler's papers and how they came to understand the physics that's with us. There's parts of it where I think in many ways Wheeler was a little goofy. He had some particularly strange thoughts about some quantum foundations stuff that I don't think hold up all that well. But the enthusiasm in this book and the relationship between her and her father is just fantastic. And I thought that was a really interesting read, and I enjoyed that quite a bit.
Excellent. Well, Chad, we will add The Theory of Almost Everything and Trespassing on Einstein's Lawn to our reading list as well. And one thing that we haven't had a chance to chat about yet are some of the places that you've been for your science. I think these opportunities to travel for conferences and to work with colleagues and for your training are a wonderful part of careers in science. So do you have a favorite place that you've been for science?
When I was in graduate school, I spent 3 months living in a suburb of Tokyo. There was a group there that was doing experiments with neon atoms. That there was a particular experiment that you could do with neon that would have been a really nice complement to stuff that we were doing in xenon. So I went to Tokyo for 3 months and stayed there and worked in a lab there and trying to get that experiment to work. Didn't end up panning out. About a week before I was due to leave, a crucial bit of equipment broke.
Oh, no.
And the lead graduate student and the PI in that lab were going to a conference for the last week. So it was like, well, we're not going to get that fixed. But it was a fabulous experience. Very intimidating to be in a place where you can't read anything at all.
Right.
And I know sort of phrasebook Japanese for speaking, but the Chinese character writing system was just hopeless. I could do pattern recognition. If you showed me the name of the subway station I needed to go to, I could sort of look at the characters and then try and match them up with ones on the map. But that was really difficult to function with. Fortunately, people there take English in school, and basically anywhere I went, I could switch to English and we could make it work and figure out where I needed to get and what I needed to do. But living in a country that's so different from the US and getting to see how things are done in a completely different context was amazing.
Definitely. And I think being able to spend 3 months there is really phenomenal, and more than just sort of the week that you would get maybe going to a conference. So were there certain things that you were able to do or see while you were there that really stick out in your mind?
I got to do a bit more tourism because I was there for several weeks. So the weekends I didn't have to work. So Nikko was the coolest place that I went on that trip, which is there's a temple there where the first of the Tokugawa shoguns is buried, but it's also way up in the mountains. So there's a spectacular waterfall near there that you can go see. And there are a bunch of temples and shrines and things there. So that was a really neat place to be. And it's way out from Tokyo. So that was really neat to get away from the city and out into that countryside.
Definitely. Well, Chad, it sounds like this was a wonderful experience, even if the science didn't necessarily pan out.
Yeah, it didn't work out, but that's science. Sometimes it works out, sometimes it doesn't.
Exactly. And I think throughout our conversation today, we've hinted at some of these human elements that are involved in science. I think science is a human endeavor, and there are some stereotypes out there about what scientists and physicists are like. And I love breaking these stereotypes on our show by talking about some of these human aspects of science and some of the fun and funny things that scientists do when they're together. So do you have a story of maybe a tradition or just a funny or fond memory of science?
The lab that I was in graduate school, there were probably 5 different experiments that were going in the group and in different rooms. And probably each experiment had 3 or 4 people associated with it. And at lunchtime every day, for a while, there was a particular postdoc, but it was a tradition that sort of everybody would gather up and we'd all go to lunch as a great big mob of people and sit together. That was enormously fun. It was always just having conversations with people from other parts of the lab about what they were doing and also just quirky things. The postdoc and I were both big fans of The Simpsons, and we used to, every week, at least one day at lunchtime, we'd end up talking about Simpsons episodes, which used to drive another guy absolutely crazy. And so he would like, "You're educated people! You're talking about a cartoon!"
I love it. Well, this lab lunch idea, I think, is awesome, especially if you're working in a larger lab, like you said, connecting with other people who you might not come across in your daily experiments.
Yeah, it was really great. And as a result, I know a whole bunch of people that we didn't really work together because they were working on a completely different apparatus than I was, but saw them every day and talked to them. So that provides a bigger community that I feel connected to.
Absolutely. And Chad, we've talked about some of the great things that you've been able to do with your research, some of the exciting questions that you're starting to answer with some of the work that you're doing with these ultra-cold atoms. So can you tell us, if we took away all of the restrictions for the work that you're doing, or maybe for science in general, is there one particular question that has been eluding you that you would love to answer?
I think if given the opportunity to really work at the infinite money limit, what I would think would be interesting to push at is just how far can you really go with the idea of quantum computers? Because that's a huge topic now, sort of as a field really is in the infinite money limit, because Google and Microsoft and the National Security Agency and various other people are throwing huge sums of money at it. But that's a thing that I think is really interesting to explore. And the things that get a lot of press are the questions about factoring large numbers, and that's tied to things like security of codes and things like that. But that's going to require really enormous quantum computers. And it's not clear how well that's going to work, but there are also a lot of problems that you could conceivably do with smaller systems. I've gotten interested in that kind of thing and does some of these simulation problems where you take a system that's relatively small, but if you try to keep track of all of the quantum properties of it, becomes a completely intractable problem to do with an ordinary classical computer. If you can do this with a quantum computer, how far can you push that? What sort of things can you accomplish? What kind of problems can you solve with that? And I think that's an area that is getting a lot of stuff, and I'm interested to see what comes out of that. There's also, if I had infinite money to throw at things, I think one of the most useful thing to throw it at would probably be batteries. If you could figure out much better battery technology, would make solar energy and a lot of other green energy a lot more efficient and practical. And that's probably the thing that would do the world as a whole the most good. But if you're just talking about what kind of curious stuff I like to see done, I'd like to see quantum computers pushed as far as they can.
Excellent. Well, Chad, two very worthy questions. And I think the second one probably resonates with a lot of us as I'm sitting here with my slowly dying cell phone. So, well, great to hear what some of these big questions are in your mind today. And we've talked about some different aspects of your career. And I think one of the things that's wonderful about science is you have so many mentors and so many people that you work with over the course of your career who can be great sources of advice. And Chad, I'd love it if you can today give one piece of advice to our listeners, maybe something that really helped you on your own path.
Probably the most influential thing that anybody ever said to me was when I was an undergrad. It was my junior year in college. In addition to being a physics major, I also played rugby. And I was probably putting more attention into that than my classwork early in my junior year. And I hadn't handed in some homework because I was too busy partying and playing sports, and I was sort of avoiding things. And the day that the homework was due, one of my professors at Williams stopped me on the way out the door and said, "Did you hand in the homework?" I said, no, there were a couple problems that I didn't quite have. I wanted to keep working on it a little bit. And it's like, because you didn't hand in the last one either. I'm like, yeah, well, I was sort of stuck on that. And it's like, I said, sometimes you just need to cut your losses and hand in whatever you have. And that made me go, whoa. And I realized I am not actually fooling anybody here. And then I went and really refocused, and I spent that whole weekend in the physics department library finishing the 4 problem sets that I hadn't handed in, and did those. And then I got a lot more serious after that. And that got me back on the right track, and it's probably the most useful thing anybody did for me in the course of my college years. So Professor Jones did me a great service there by just saying, sometimes you just need to cut your losses and hand in whatever you have.
Well, I think that's a great wake-up call for you in this situation where you were maybe not focusing on your studies, but I think in general, the message is really helpful in science because so often I think we get fixated on getting everything completed and everything perfect, but that can stop you from really making progress.
Kind of goes back to the work, finish, publish. You have to do the work, and you also have to, at some point, not get caught up in endlessly chasing side issues and going down rabbit holes. And at some point, you have to be finished. You have to get through things, and you're maybe not answering every single question that you have, but there's a point where you've done enough that it's time to hand it in and publish it and get on to the next thing.
Absolutely. Well, great advice for our listeners, Chad. Is there any last piece of advice you'd like to leave them with, or a last message of inspiration you want them to have?
One of the things that I try to do with the books and other stuff is to demonstrate that we have this tendency to put science off on a pedestal and to say scientists are just these super smart alien people who are really special. And I think there's a sense in which that's flattering to great big nerds like me. Mm-hmm. But there's also a sense in which that's really sort of corrosive and not very good for society as a whole. So I think the thing that I try to communicate to people through doing the general audience books and promoting science is to try and make clear to people that scientists are people just like anyone else. We're not aliens. We're not people who think in a completely different way than anyone else does. We're just interested in particular things. And the mental tools that we're bringing to bear on problems in science, it's the same toolkit anybody else has. Absolutely anybody can, with a bit of effort, understand what's going on in science. And people shouldn't be put off from science just because it's sometimes made to seem like this weird alien activity. It's actually as human as you get.
Absolutely. Well, Chad, I love this message. And I also just want to tack on here that I always worry that people feel intimidated by scientists because they put them in this box of only thinking them as a scientist. But like in your case, you're a father, you love dogs, you play basketball, you have all of these different facets to you that I think a lot of people sometimes forget.
Exactly.
Well, Chad, if people want to learn more about you and the wonderful work that you're doing, where should they go or how should they get in touch?
Probably the easiest way to find me, particularly when I'm trying to waste time, is on Twitter. I'm at OrzelC, that's ORZELC. I spend a lot of time there when I'm trying to pass the odd hours.
Get writing done too, yeah.
Yeah, and sometimes there's sort of half-formed ideas that I throw out there. But everything else ends up coming back to that. I link to stuff that I write on the various blogs. I'll link to from Twitter so you can find that. So that's probably the easiest place to find me.
Perfect. Well, listeners, definitely follow Chad on Twitter to keep up to date on what he's thinking about. And Chad, thank you so much for joining us on our program today to share a piece of your story.
Thanks for having me on. This was fun.
Well, it was a pleasure to chat with you, and thank you again for joining us. Listeners, great to have you here as well. We'll see you next time on another episode of People Behind the Science.